Hello everyone. In the last class, we have seen the equivalence formula, how to obtain or how to show the equivalence between two formulas by using truth table and without using truth table. Okay. But in the last class, we have seen how to check whether two statement formulas are equivalent with each other by using truth table. But in this video class, we'll see how to show the equivalence between two formula without using truth table. At that time, we have to use the standard laws. In the previous class, we have seen basic demonstration. Now in this class, we'll see the standard laws. Already we have learned these laws carefully. First, domination laws. Second one, identity law, independent law, De Morgan's law, double negation law, negation law, commutative law, associative law, distributive law, absorption law. Okay, so these are the laws regarding the basic connective, conjunction, disjunction, and negation. Okay, secondly, we have seen in B section laws related to condition law, and in third section we have seen laws related to bicondition law. So there are two laws. So by applying all these laws at the same time, it is not possible to apply all these laws, but as per requirement, we have to justify or we have to get idea which law is applicable for which situation. Okay, that is a very easy task, but for that, we require lots of practice. Okay, we'll see with the help of example directly. See, show the following equivalence without using truth table. Okay, very simple thing is here. Now my question is P conditional Q equivalence with P or Q. When an example is given to you, here we have to find left hand side equal to right hand side, or first find out the left hand side, find out the right hand side, and then compare the result of left hand side and right hand side. If both are same, then we can say equivalence is present. Okay, so directly we'll first see, we'll take left hand side. Now what is my left hand side? P conditional Q. Okay, by looking toward this, we'll get idea. Here condition sign is present, so definitely we can apply condition law. Okay, so firstly solve bracket. I can apply condition law for this bracket. So what condition law indicating? First part is negation, second part as it is, and in between them we are using disjunction. So apply over here. By applying the condition law, we'll get negation P or Q. Remaining thing keep as it is. Go step by step. Secondly, condition sign is there. Okay, so before condition sign, whatever things are present, that we can consider as a P, and second part means after the condition we can consider as a Q. Okay, if you apply condition law over here, so we'll get negation of all this bracket. Hope all of it is clear. And second part Q as it is. Now see, I'm applying negation to all this bracket, second part Q as it is. Then now by looking toward this, we'll get idea. Negation sign is present outside the bracket. Can we apply inside the bracket? Yes. So that law indicating De Morgan's law. So apply it. De Morgan's law. See, negation applying to each and every individual atom proposition, but inside the bracket sign get change. So here or is there. So after applying condition, sorry, after applying negation inside the bracket, we'll get and negation to this negation P, negation to this Q, and sign become and. Remaining thing keep as it is. Okay. Now see, by looking toward this, again we'll get negation present outside the bracket. Again inside the bracket, negation is there. So at that time we can use which law? Double negation law. Negation P equivalence with P. So we'll get here by applying double negation law, P and Q or R. Okay. At last we'll get here. Now by looking toward this, we'll get idea which law is applicable. So for that, inside the bracket and outside the bracket, just check the sign. Whether the signs are same? No. Signs are different? Yes. So definitely I can apply distributive law. Which law? Distributive law. Okay. So what distributive law indicating? Whatever atomic proposition and basic connective present outside the bracket, that enter inside the bracket. Okay. Now apply here. See here. Q or P or P or Q. We are keeping and as it is. Q or negation Q. By applying distributive law over here, we'll get this simplification. Now again by looking toward this line, just check which law is applicable. Now here one thing is there, Q or negation Q. We have one law, negation law. If you remember, P or negation P always equivalence with true. If P or negation P equivalence with true, then definitely Q or negation Q equivalence with true. Yes. So by applying negation law, we'll get P or Q and true. Hope all of it is clear. At last, now see here again we can apply one more law, identity law. Now see, before and P is there, before after and T is there. If you are performing ANDing operation P and T, will get result as a P. Now check here, before and this whole bracket is there, I can consider as a P. After and T is there. So is it same like as a P and T? Yes. If P and T is there, equivalence with P. So here P or Q, I'm considering as a P. Ending with T, definitely will get as a P, nothing but P or Q. So here at last we'll get the result that is same as like right hand side. So at last we can say, hence prove, or we can say confidently, equivalence is present in between these two statement formula. Okay, so this is the method to get equivalence between two formula by without using truth table. Definitely we have to apply these particular laws systematically. So at last we'll get proper solution.